All right, so we set up the Cartesian plane, the x-axis, the y-axis, for a parent function of sine or cosine. So let's graph the sine function. You should have your unit circle with you. If you're ready to challenge yourself with the sine values of all the important angles on the unit circle, great, because I'm here with you, but you should probably not be at that spot yet, and use the unit circle as we go through translating from the unit circle to the Cartesian xy plane. All right, I'm taking the graph I just made in the previous video, and I will be making more of these. You're gonna have to keep watching the videos to make them yourself. So we're doing y as sine of x. I like to say theta. The book seems to like x. They're it doesn't really matter because they're the same variable. Theta is just kind of neater and cooler in my opinion. All right, we are going to start at 0. So you should be looking at your plates. We are talking about the different angles on the x-axis, and we're going to put a point for the y value. Remember, now don't get confused with this y or x. When we have an angle like pi over 6, it has an x coordinate and it has a y coordinate. Its x coordinate is rad 3 over 2. Its y coordinate is 1/2. And x's stand for cosine and y's are sines. So here we are only graphing the sines, which means we're only graphing the y values of the angles on the unit circle. Okay, so actually let's start with 0. So let's look at the y coordinate of the degree 0, and it is 0. So let's make a nice dot. I said already the y value of pi over 6 is 1/2, so that goes right here. Remember, pi over 6 is my first box if you're setting up the way that I do it. Let's look at pi over 4. It is rad 2 over 2. So get out your calculator, and you're going to want to start remembering this, but square root of 2 over 2 is about 0.71, let's say. So if this is 1/2, and this is 3/4, which is 0.75, so this would be around here. Pi over 3, its y value, the sine of pi over 3 is rad 3 over 2, and that's about 0.87 or 0.866. So again, if this is 0.75 and this is 1, then 0.866 is going to be somewhere around here. And pi over 2, the sine of pi over 2 is 1. All right, that's not perfect. I can adjust the dots later if I need to. Let's keep going though. Sine of pi over 2 is 1, so the sine of 2 pi over 3 is down at 0.866. Sine of 3 pi over 4 is here at 0.707, and the sine of 5 pi over 6 is 1/2. Let's look at the sine of pi. The y value for pi is 0. All right, let's see what happens next. We go to 7 pi over 6 on our unit circle, look at the y value, and it should be at -1/2. Oopsies, that should be on the crosshair. Sine of 5 pi over 4, that's going to be negative rad 2 over 2, which was -7.1, which is not at 0.75. Oopsies, I should be halfway. It's going to be right around here. Sine of 4 pi over 3 is not at 0.75. It's not at 1. It's negative rad 3 over 2, which is about -0.866. Finally, the sine of 3 pi over 2 is -1. Now, what do you think is going to happen over here as we go to the sine of 5 pi over 3, 7 pi over 4, and 11 pi over 6? It's going to be a reflection, right? The pattern holds. We have the sine of 5 pi over 3 is negative rad 3 over 2. The sine of 7 pi over 4 is negative 0.707. Negative rad 2 over 2, which would be around here. 11 pi over 6 is -1/2. And finally, the sine of 2 pi is back to 0. I know that was a lot. You can go through your plate, which we should have practiced already. We're just graphing the y values. Okay, as curvy as possible. Now keep in mind that this curve is not consistent. It's beautiful, but it's not consistent. So it's super steep in some parts, then it levels off, and then it turns around. Okay, there are no jagged edges. Even down here in this valley, it's a curve. Even at this mountaintop, it's a curve. And it's going to continue, right? We can keep going around the circle, which we're not going to do just yet because we're going to go backwards. Okay, so back to 0, which I guess we were at already. We just need to go backwards. Now, negative pi over 6, we're going clockwise now, okay? It's not going to go up here, right? Negative pi over 6, that's the same as 11 pi over 6. Negative pi over 6 is at negative 1/2. Negative pi over 4 is down here at negative 7.07. Sorry, negative rad 2 over 2. I don't know why I'm apologizing, though. I'm not actually sorry. Negative pi over 3 is negative rad 3 over 2, which we thought was right here. Negative pi over 2 is negative 1/2. Okay, remember, we are now going clockwise from 0. Okay, now, if you're still unsure of what we're doing, we at least started a pattern, right? This is a sine wave, it's a sine curve. So we can't just skip up here or anything. We are at negative pi over 2 on our x-axis, negative 1 on our y-axis, okay? So that's where we are. We're going to negative 2 pi over 3. We're going to go back to here. We're going to go to negative 3 pi over 4, which remember I didn't label on my negative axis in the previous video. Axis. Negative 5 pi over 6 is at negative 1/2, and negative pi is at 0. Negative pi should be the same as pi. Okay, now where are we going? We're going up here in the positive values. Negative 7 pi over 6 is the same as 5 pi over 6. So negative 7 pi over 6, its sign is positive 1/2. And then right in between at negative, what is this, 4 pi over 4, negative 5 pi over 4. Remember, I didn't write it. I just put a tick mark on the x-axis. And then here on the blue line, negative 4 pi over 3 is going to go up here. And we should all be together at negative 3 pi over 2, comma, 1. All right, and then back down one more, finish off the mountain. Okay, and I'm going to start from left to right. We're being curvy. Even up at that peak at the top of the mountain, we were curvy. And let's add in arrows because this is cyclical. It's a circle. It continues to positive infinity. It can go backwards to negative infinity. It is a wave. It never stops. We have a maximum at 1. We have a minimum at negative 1. We only chose to graph the parent function between negative 2 pi and 2 pi. We could have kept going. You might have a problem like from the book that wants you to graph out to 6 pi, so you graph out to 6 pi, right? We used 1/2 and 1 as our markers to kind of keep us on track, and we have negative 2 pi and 2 pi at either end. Okay, so this was the parent function for y equals sine of x. Before your next video on cosine, you probably should draw another blank graph, and we will do the cosine function together.